I was asked to solve these couple problems. So number 20, 21, and 22 are asking you to decide whether these functions are even, odd, or neither. So to do this, we always look at f of negative x. So if I do that for this first one, I'll have negative x cubed minus 3 times negative x. So that will be negative x cubed plus 3x. And if f of negative x is the same thing as f of x, it's an even function. That's not the case here. If f of negative x is equal to negative f of x, it's an odd function. So negative f of x would be negative x cubed minus 3x, but that is negative x cubed plus 3x. Notice that these two are the same. So this is an odd function. For the second one, again, we look at f of negative x, and we're going to have negative x to the fourth minus negative x cubed. So this will be, so since this is being raised to an even power, this will be x to the fourth, and this is raised to an odd power, so a negative will pop out. So this will be plus x cubed. All right, this is not the same thing as f of x, so the function is not even. If we look at negative f of x, we're going to have negative x to the fourth minus x cubed. That's negative x to the fourth plus an x cubed once I distribute. Notice that this negative f of x is not the same as f of negative x because I have this minus sign right here. So that tells us that the function is not odd. So this one is neither even nor odd. Last one, let's look at f of negative x. This will be negative x cubed plus negative x squared minus 3. This is going to give us negative x to the third because it's raised to an odd power plus x squared, it's raised to an even power, minus 3. Again, this is not the same thing as f of x, so this function is not odd. And if I do negative f of x, I'll have negative x cubed, negative parenthesis x cubed plus x squared minus 3. This is going to be negative x cubed minus x squared plus 3 once I distribute. This is also not the same as f of negative x, so this is not odd. And I just noticed that I said the wrong thing up here. This is not even because f of negative x is not the same as f of x. And it's not odd because negative f of x is not the same thing as f of negative x. So that's how you go through those problems. Let me stick an extra one in here that will be even, just so you can see how that works. If we do f of x, this is an extra example, f of x equals x squared plus 2x to the fourth plus 2, then f of negative x would be negative x squared plus 2 negative x to the fourth plus 2. But the x's are raised to even powers, so I'm just going to have x squared plus 2x to the fourth plus 2. So that means this one, this is an even function. Okay. I was also asked about numbers 23 through 25, so let's do those. These are all piecewise defined functions. So g of x is defined to be x squared minus 7 over x minus 2 if x is not equal to 2, and it's defined to be x plus 4 if x is equal to 2. Now, I want to evaluate g of negative 2. So I have to decide which of these two piecewise definitions do I use. Well, I care about when x is negative 2, so that's going to be down here. So g of negative 2 is going to be negative 2 plus 4. All I did was I plugged in negative 2 where that x is, and that's going to give me 2. So that's the answer. G of negative 2 is equal to 2. For 25, I want to graph this piecewise defined function. So this function changes definition at 1. So I'm going to make a table where I look at x values that are smaller than 1. So I'll look at 0, -1, and -2. So f of x of those is going to be using this definition. So 0 minus 3 is -3. -1 minus 3 is -4. And -2 minus 3 is -5. So my points that I plot f of x are going to be 0, -3, -1, -4, -2, -5. And this is all for x strictly less than 1. If x is greater than or equal to 1, my table is going to look like this. I'll go 1, 2, 3, but this is constant, right? F of x is equal to the same thing. So this is -4, -4, -4. So the points that I will plot are going to be 1, -4, 2, -4, 3, -4. And now I'll just plot those points. So here's 1, 2, 3, 4, -1, -2, -3, 1, 2, 3, 4, -1, -2, -3, -4, -5, and so on. So I have the point 0, -3 on my graph. I have the point -1, -4 on my graph, and I have the point 2, -5 on my graph. And I also have the point 1, -4, 2, -4, and 3, -4. So when I draw the line connecting these, so in the positive direction, it's gonna, that is awful. Let me try to draw that line again. The positive direction, it's going to go this way. In the negative direction, it's going to go this way through these points. And now what do I do with this in between side? So if x is strictly less than 1, this is the definition that I use. I only use this definition if it's greater than or equal to 1. So that means I need to continue this shape until I get to -1 and there's a hole there. And that's the graph of that function. And the last question is another one about evaluating these piecewise defined functions. So I want to find f of 2. That's going to be in this part of the definition. So f of 2 is going to be 2 times 2 plus 1, which is just going to be equal to 5. All right, I hope that's helpful.